Now let's start with section C, deep learning. The question states compute probability. A fair die rolled twice. Probability that sum equals 7 is p equals to. So a fair die is rolled twice. What is the probability? That the sum of the two rolls is 7. Now count all total possible outcomes. Total outcome would be 36. Then favorable number outcomes where sum equals 7 is equal to 6. Then probability would be 6 by 36. Then 1 by 6 would be the probability. Moving on to the next question. Uh, it is for binomial distribution n equals 10 equals 0.5. The expected value would be, of course, n into p, which gives us the answer 5. So now moving on to the next question, if r square equals 0.8 and TSS equals 100, compute RSS with the formula r square equals to 1 minus in bracket RSS by TSS. It gives us the answer RSS equals 20. Now, in the next question, in linear regression, gradient descent update rule for weight W equals to W minus alpha x. Uh, the equation is W equals W minus alpha into delta of J by delta of W. For a normal distribution, 0 comma 1, what percentage of data lies between minus 2 and plus 2? So between minus 2 and plus 2, approximately 95% of data lies in the normal distribution curve. Well, the exact uh, percentage would be 95.4% of the data. Now, moving on to the next question. For k-fold cross validation with k equals 5, each iteration uses what percentage of data for training? So it approximately uses 20% of validation proportion, and training proportion is 80%. So 80% of the data is used for training in each iteration. The next question, compute precision if TP equals 40, FP equals 10, then uh, precision would be around 0 0.8 or say 80% according to the formula. If recall equals 0 0.8 and precision equals 0 0.4, F1 score equals 0.53 according to the formula F1 minus 2PR upon P plus R. Uh, so in the next question, our model gives TP equals 70, Tn equals 80, F equals 20, Fn equals 30. The accuracy would be 0.75 or 75 percentage according to the formula of the accuracy, as we know. For a Poisson lambda is equals to 3 distribution, expected value would be 3 according to the formula for Poisson distribution related questions. Uh, Now let us uh, delve our mind into section D, which is Python data structures, one-line command instruction. So there are several codes we have to write. Uh, let's start with question number 26. I'll be repeating the sequence of questions one by one from the Jupyter Notebook interface. Now the first question says compute mean of list A equals 2, 4, 6, 8 using NumPy. So it would be like import NumPy as NP A equals 2, comma 4, comma 6, comma 8. mean val equals np dot mean of a mean of val, then it gives me the answer. The question two would be like convert list 1 comma 2 comma 3 to a numpy array. Arr equals np dot array of in array 1 comma 2 comma 3 arr, which gives me the array. Create a data frame from dictionary a 1 2 b 3 4. Import pandas as pd. Df equals pd dot data frame, where a is connected to 1 comma 2 and b is connected to 3 comma 4, and df to take the output. Then the fourth one is like replace all missing values in a data frame df with column mean. Df equals df dot fill an a of df dot mean. It is a function, and df to get the output. And the next question, display first 5 rows of data frame df. It would be done by df dot head. Then plot histogram of column height using matplotlib. For that, we have to import a matplotlib.pyplot as a plt. It would be like plt.hist of df, in which the array argument would be height. Then plt.xlabel, the argument would be height. Plt.ylabel, the parameter would be frequency in string. Plt.show to have the uh, plot histogram of uh, column height using matplotlib. The seventh would be like one hot encode the categorical column color. Df encoded equals pd dot get dummies of df comma columns equals to array argument color. Df encoded to get the output. Then compute correlation between columns x and y. Correlation xy equals a df array argument x dot correlation xy, what would be like a function argument df, array argument y, and then correlation xy. The next question, find unique elements in list A using Python set. Unique wells equals set of A, then unique wells to print the set. Then add a new value, key value pi 3.14 to dictionary D. It would be like D argument pi in string equals 3.14. Then create a deck and append elements 1, 2, 3. Uh, to do that, you would import uh, from collections uh, deck, and then dq equals to deck, dq dot append 1, dq dot append 2, dq dot append 3, and then print dq. The next question is pop smallest element from min heap. Import heap q. Then smallest equal to heap q dot heap pop of heap, and then smallest to print the heap. Print smallest element from heap. Then create numpy array of zeros with shape 3 comma 3. Zeros underscore arr is equals to np dot zeros of 3 comma 3. Zeros underscore arr for printing it. Then convert column date to date time in pandas. Df in argument date equals pd dot to underscore date time as function, and then in argument df argument date in strings df dot d types. And then the last question in this section, uh, filter data frame rows where score is greater than 50. Filtered underscore df equals a df in argument df in argument score in strings is greater than 50, and finally filtered underscore df to get the output. Uh, with this, we have completed section C and section D. And in the next video, we will be solving section E, analytics oblique application. Thank you so much for watching this video.